Today, we're going to introduce and explain L'Hopital's rule and how L'Hopital's rule is used to find certain limits. Some limits don't have any issues. For example, I'll just make this up. If you're doing this limit, let's say of x plus 4 over x squared as x tends to 1, you substitute 1, there are no issues. Okay, 1 plus 4 over 1 squared, and this is equal to 5, no issues. We don't use L'Hopital's rule in this situation. Here's another one that's also not an issue. Limit of x over x minus 1 squared as x tends to 1. This time there is an issue, a small issue. When you substitute 1 down here, you end up with 0 in the denominator. The numerator is plus 1, the denominator is 0. So this limit, when you divide 1 by 0, this is plus infinity, not an issue. So these aren't the ones where we use L'Hopital's rule for. The ones we use L'Hopital's rule for are limits like this, like limit of sine x over x as x tends to 0. The numerator sine 0 and the denominator 0 is 0 over 0. 0 over 0 is a special limit. It's a special form. So you use L'Hopital's rule whenever you end up with one of these forms. Okay, the forms 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, and 1 to the power infinity. These forms are special forms, are indeterminate forms. Indeterminate forms. And all this means is that these forms are incomplete. So none of these is an answer. All of these can be simplified and they can be determined. If you could simplify them and find the limit, that's great. But the first two forms we can use L'Hopital's rule for. This is what L'Hopital's rule states. It states the limit of f of x over g of x as x tends to any number or to infinity. If this limit here is infinity over infinity or 0 over 0, let's call this limit L. We'll call it L. So if this limit L ends up being infinity over infinity or 0 over 0, we can determine it by doing this. Then L is the limit of, take the derivative of the numerator alone, f prime of x. Take the derivative of the denominator alone, g prime of x. And then x would tend to wherever it did before, c or whatever. Then you find the limit again by taking the derivative of the numerator and the denominator. Take this ratio and find the limit, and it might work. If it doesn't work, differentiate one more time. Note, this is not the quotient rule. So we're not using the quotient rule. We're just differentiating numerator and denominator separately. Let's do this example. This limit here is 0 over 0. So it qualifies as an indeterminate form of limit. And we're going to find it by using L'Hopital's rule. So limit of sine x over x as x tends to 0 is sine 0, which is 0 over 0. That's indeterminate. So what do? Take the derivative of the denominator and the numerator. So this is equal to limit as x tends to 0. We'll do the numerator first. The derivative of sine x is cosine x. The derivative of x is 1. And then retake the limit. When x tends to 0, cosine of 0 over 1. This is 1 over 1, so the limit is equal to 1. We were able to determine it. And that's what L'Hopital's rule states. So if you end up with these two forms, you can use L'Hopital's rule for. If you end up with one of these, you can rearrange it and turn it into one of these forms, so you can still use L'Hopital's rule for those. Let's call this example 201. Let's do 202 now. Limit of 3x squared minus 10 over x squared plus 4 as x tends to plus infinity. You get the same result when x tends to minus infinity in this case. when you substitute infinity, infinity squared is infinity, infinity squared down here is infinity. So that's an indeterminate form. We're going to use L'Hopital's rule to do this. Limit as x tends to plus infinity. The derivative of the top is 6x. The derivative of the bottom is 2x. 6x over 2x can be simplified. It's equal to 3. So the limit is equal to 3. The limit of 202 is equal to 3. Limit ln x over x minus 1 as x tends to 1. First substitute 1 and see if it works. If it works, it's great. When you substitute 1, ln of 1 over 1 minus 1, ln 1 is 0, 1 minus 1 is 0, indeterminate form. So now we need to take the derivatives. The derivative of ln x is 1 over x. And the derivative of x minus 1 is 1. So now substitute 1. 1 over 1 over 1. This is equal to 1. So this limit ends up being 1. It's no longer indeterminate. It's equal to 1. Limit of sine 3x over sine x as x tends to 0 is sine of 3 pi is 0 over 0. That's indeterminate. So take the derivative. Limit as x tends to 0. The derivative of sine is cosine 3x times the derivative of 3x is 3. So times 3 over the derivative of sine, which is cosine x. Substitute 0 now. Cosine of 3 times 0 is cos 0, which is 1 times 3 over 1. So this limit is 1. Let's redo this problem and make x tend to pi. Okay, if x tends to pi, the limit is still sine 3 pi is still 0, sine pi is still 0, so it's still indeterminate. The derivative of sine 3x is this, the derivative of sine x is this. Now we're going to substitute x equals pi. Okay, cosine of 3 pi is the same as cosine of pi. And that's equal to negative 1 times 3. And the answer is 3. Let's do 205. When x tends to 0, e to the power 3 times 0 is 1 minus 1. And then the bottom is 0. 1 minus 1 is 0 over 0. Indeterminate form. We're going to use L'Hopital's rule. So this is equal to the limit as x tends to 0. The derivative of e to the 3x is e to the 3x times 3. Chain rule. Minus the derivative of 1, 0. The derivative of x is 1. Now let us substitute x equals 0. E to the 0 is 1 times 3 over 1. So the limit is 3. Limit of sine x over e to the 2x minus 1. Sine 0 is 0. E to the 2 times 0 is 1 minus 1 is 0. Indeterminate form. Let's take derivatives. So limit as x tends to 0. Okay, the derivative of sine x is going to be cosine x. And then the derivative of e to the 2x is e to the 2x, it's itself, times, use the chain rule. The derivative of the exponent is 2. Minus 1, the derivative of 1 is 0. Now we substitute x equals 0. So cos 0 over e to the power 2 times 0 times 2, which is 1 over 2. So this limit is equal to a half. Limit of 4x divided by tangent x. When you substitute 0 here, you get 0, tangent 0 is 0. So it's indeterminate. But this time, I'm going to simplify this before using L'Hopital's rule. I'm going to write it like this. Limit as x tends to 0, 4x. Now, I'm going to write tangent x as sine x divided by cosine x. You can divide it here by cosine x, or you can bring the cosine up. And what I'm going to do is substitute x equals 0 down here. If you substitute x equals 0 down here, cos 0 is 1. Get rid of that one. So it will be, so this is equal to 1, so this will be limit of 4x over sine x over cosine x is x tends to 0, and this is equal to 1. Now I'm going to differentiate the rest. Actually, before I differentiate, I want to do this. 4x over sine x times cos x. And I'm going to do these limits separately. This limit and this limit separately. So this is limit of 4x over sine x times limit of cos x as x tends to 0 as x tends to 0. I could have got rid of it from here, but I just wanted to show you that you can get rid of it by doing this, and you don't even have to do this. This limit is equal to 1. This is indeterminate. So use L'Hopital's rule for this one. This is limit. The derivative of 4x is 4, and the derivative of sine x is cos x times 1. So this is 4 over 1 times 1, which is 4. So this limit is equal to 4.